Okay, what is a log? One word definition. A log is an exponent. If a log is an exponent, then the properties of logarithm have to be the same as, and here are your properties of exponents right here. You have a product property, you have a quotient property, and a power property. What's a log? An exponent. The product property, what do you do with your exponents? Add them. Quotient property, what do we do with our exponents? Subtract. In power property, what do you do with your exponents? Multiply. Remember, a log is a power, so the properties of logs are going to behave just like these properties of exponents. This is at least the third time, it might be the fourth, that these have been in your notes. You should have flashcards on these because they don't go away. Properties of logs are going to behave like the m's and n's on this page. So we're going to have three properties to start with of logs: product, quotient, and power property. And the way that it works is that if you have the log of a product, m times n, you're going to separate them into the sum of two logs. The log of a product.
So you do it backwards?
No, I don't think so.
From an exponent form?
Well, let's go back and look. What are we doing when we're multiplying here? You add the powers. That's exactly what we're doing right here. You have the log of a product becomes the sum of two logs. Now the middle one here, this quotient property, you need to be very careful about the quotient property because the quotient property looks extremely similar to a property that we'll do here in about 20 minutes. The quotient property is the log base b of literally a quotient. Okay? It does not say log divided by log. That's what I want to stress here. This is the log of a quotient. The log of a quotient. As opposed to a log divided by a log. That's something totally different. The log of a quotient becomes the log of the top minus the log of the bottom. And then the power property, log base b of m. Log base b of m is a power. N is also a power. What we do is we multiply them together. We drop the power n in front of log base b of m. N log base b of m.
So you don't multiply it by n?
By what?
By n.
Well, m isn't something that you're multiplying. It is what you're taking the log of.
Okay.
It's log base b of m. That's one thing.
Yeah.
And so when m is raised to a power, the power goes in front. But the log base b is one entity. I go back and forth on these first three questions on whether or not I should show them to you or not, and whether or not they're relevant. I think that they're good because they're good thinking problems, good analytical problems, but I'm not sure that it matters to us about these decimal values that are here and here. What I think, if you understand this, if you could get me log base 3 of 12 and log base 3 of 2, if you could get to 12s and 2s with base 3, I think I'd be good with that. Okay? They want you to get all the way down to a decimal value. Now, how are you going to get to a decimal value? On your calculator, for everybody, what is one base that's on your calculator? So what base? 10. And the other base that's on every one of your calculators is E. Those are the only two that are on all of your calculators. Now, some of you can put any base you want in your calculator, and that's great. It doesn't matter, you still got to show your work, you still got to do all the stuff that everyone else does, but you do have that luxury And there's probably maybe 6 or 7 of you in here who have that calculator. Great. Your other choice is to use a table. We have log tables in the back of books. I don't know if there's one in your book anymore because nobody uses it. Or you could memorize bases. Like you could memorize base 3, for example. Log base 3 of 12 is 2.262. Does anyone want to volunteer to memorize base 3s for the class? We'll give you extra credit. Does anyone want to do base 4s?
How many bases are there? Or like how
Well,
many?
a base can be any number,
Okay,
right?
yeah.
I'm just looking, if we had someone who knew each of the bases, things would go really fast. I only want you to pick, you only have to volunteer for one base. Like if you knew all of the base 3s, and we had a base 3 question like this, I could say, you'd be our expert.
How much extra credit?
How much do you want?
That's not a big
I'm sorry?
deal.
You can set your own number. Don't be stingy. How much? 8,000 points. You got it. Is that enough? In this class?
So I get an A.
What's that?
Automatic A.
Automatic A.
Whoops. Alright, so
No, he's not.
it's because there's infinite numbers that count.
But I want only base 3 is all I care about if that's the one you're choosing to volunteer.
Yeah.
No, not base 2, not base 4, just base 3. I'm not trying to get you to memorize every base, just one base.
For what?
3 decimal places.
I don't know what the question is.
I want you to memorize log base 3 of 1, log base 3 of 2, log base 3 of 3, log base 3,
All the way
up to, let's say to 100 would be fine. Any takers? Tyler's really thinking about it.
No, I'm not.
Good. Because it's ridiculous. All right? So in this problem, what we want to do is utilize these properties instead, because we know what log base 3 of 12 is because they're telling us. And we know what log base 3 of 2 is because they're telling us. And I need to be able to take log base 3 of 6, and if I know these guys, is there a way I could write log base 3 of 6 using the 12s and 2s? The decimal values have no value to us right now at all.
Well, 2 times 6 equals 12.
That's true, but we don't have 6. We only have 12s and 2s. And I want to rewrite this using 12s and 2s.
Or multiply that.
I have too many people.
Multiply that log base 3 of 2.
Nope.
Log base 3 of 6 times log base 3 of 2.
Nope.
Multiply the 2 of
Log
2.
base 3 of 12 divided by log base 3 and 2.
That's the danger that I'm talking about. You're on it, but you made up your own property. Look at the quotient property. It doesn't have the word log twice. You said log divided by log. That's not this property, but you're really close. If you utilize that property, you'll be all set. What should it be? Log base 3 of 12 divided by 2. We're going to change log base 3 of 6 into log base 3 of 12 over 2. How does that help us? How does that help us? We have log base 3 of 12 divided by 2.
We divide our 2 just rewrite it.
How?
We'll fix one more thing. We plug in, we just do 2, 4, 6.
No. If you bear with me, I'll go back and answer that question.
Log base 3 of 12 minus log base 3 of 2.
Log base 3 of 12 minus log base 3 of 2. Because this says log base b of m over n is log base b of m minus log base b of n. It is the quotient property for logs. Log of the top minus log of the bottom. What's a log? An exponent. If if you have the log of a quotient, what do you do with your exponents in a quotient? You subtract them. Log of the top minus log of the bottom. Why do we do log base 3 of 12 over 2? Because we have to use the number 12 and the number 2 in such a way to get 6. 12 divided by 2 is 6. I only rewrote this because I know 12s and I know 2s. Once I get to this stage, log base 3 of 12 is 2.262. And log base 3 of 2 is 0.631. So log base 3 of 6 is whatever you get when you subtract those. 1.631. Okay, all the knowers, what is it? It is 1.631. I don't know. I don't think they have any faith in Chase because he's legal.
Oh.
Well, he's
1 minute on time.
No, you're on time, but geez, barely. That's the answer to log base 3 of 6. Why? What do you, tell me what to show. What do you want to show?
I believe this is probably
Skip writing? So we're going to do it telepathically?
well, when you asked what could we rewrite it as, I went straight to the numbers.
These numbers? But you started with log base 3 of 6. These numbers make no sense from log base 3 of 6. So if you want to get credit, and I'm fine with not giving you credit, you can go right to the answer for all I care. But we would love to see the process that went through your mind written down so you can get full credit. No, yeah? Okay, then therein lies a bigger problem for you. Because this is the only process that I can see. I am open to other suggestions. And sometimes there are other ways to do this. In fact, I can see looking at it a different way to do it. But you would have to show me what your way is. And the Ouija board is not going to fly. It just came to me, Mr. Locker. I just knew it. Yeah, not so much. This is worth 3 and you have this. I might give you a half a point. But you said you can't show this work because that's not the work that went through your mind.
No, I didn't say that. I said
Oh.
this didn't go through the mind. I just went straight to the numbers.
But again, without this process in your head, what's that? Well, I would really rather you understand why we went through this process. Okay. Another way to do log base 3 of 6, with only knowing this, and what you've learned so far about logs, there is another way. See if anyone can pull that out of their hat. There is another way to do log base 3 of 6, if this is all you're given, plus what you have learned in the last week or so in logs.
Only knowing the 12.
Well, this is what's given. I'm not giving you any other information, but you know information that can help you.
Okay, you just do like 3 to the 6.
No. Ignore the blue. Here's the problem, and you're going to do this problem. This is one way to do the problem. That's another. Yeah, but in order to do that, you'd have to go 3 to some power equals 6, and unless you know your base 3s, but no one volunteered, so we wouldn't be able to do that. This is a no calculator problem. You don't need a calculator. What's another way to write 6?
3 times 2.
3 times 2. If you do log base 3 of 2 times 3 or 3 times 2, the order doesn't matter. How can we apply the product property now?
Log base 3 of 2 plus log base 3 of 3.
Log base 3 of 2 plus log base 3 of 3. What's log base 3 of 2? Flush.
0.64.
0, a little dyslexia there. 631. What's log base 3 of 3?
12 divided by 1. Log 0.3.
Log, where the base and what you're taking the log of are the same, it's always going to be 1. 1.631.
Tell us about these scenarios.
No, I mean, it's just a scenario. It's just different than this. Log base 3 of 24.
It's log base 2 of
12 times 2, which is log base 3 of 12
plus
plus log base 3 of 2. So now it's 2.262 plus 0.631, 2.893. Again, these are just doing the analysis, really. You got 2's and 12's. What can we do for this one? Huh? Same problem. Different question, same.
Can you like log 2 and
Log base 2,
can you like do more than just 2?
do as many as you want.
Like log 5 log.
2 times 16? 16's not on my
You got
list.
log base 3 of 2 log times log 3 plus log base 3 of 2 plus
Before that, what would you write?
log base 3 of 2. Okay.
That would be a good way to go. I'm doing this problem using the same directions. Why would we want to do this? What can you do with log base 3 of 2 to the 5th? What do you do?
5 log.
Drop the 5 in front. 5 log base 3 of 2. And log base 3 of 2 is 0.631. 5 times 0.631. 3.55?
Yeah.
155. Is that right?
Yeah.
3.155. What's that? That's what log base 3 of 32 is. 3 to this power is 32. I used only the 2. Didn't need the 12. Well, I didn't use the 12 here either. All I need you to be able to evaluate is this, knowing what you know. In these problems, you're not going to have these problems on a test. You might have one. They're not what this stuff is about. It's about knowing the properties. This is just an application of it. Okay, let's take a look. Expand means apply the property. Expand means apply the property. What would this look like if you expand it? What's it going to look like if we expand this?
2 to the x equals.
No.
It's log base 2 8
Log base 2 of 8
plus log base 2
of x. And then, of course, I said then, of course,
2 to the 3rd.
2 to the 3rd. So what's log base 2 of 8? What is it?
2 to the log. Oh, to the 4. Log
2
base
to the
2.
3rd.
What is log base 2 of 8?
Oh.
Log base 2.
Oh. Oh.
Equals 3. You need to know your definition of a log. A lot of you are kind of skirting that. Yeah, I kind of get it, but not really. You need to understand log base 2 of 8, that's an exponent. The exponent is saying 2 to what power is 8? Well, that one's 3. If this is a 7, then you're done. But it's not. It's an 8. So you put 3 plus log base 2 of x. If you can simplify, you simplify. Expand this one. The first thing you should recognize is that this is log of a quotient. So the first thing that we can do is we can take log base 7 of the top minus log base 7 of the bottom. Bless you. That is the quotient property for logs. If you look at the property, hopefully you wrote it down. Log of the top minus log of the bottom. Make sure you have a base 7. Make sure it's below the word log. 3x is on the same line as log, and 2 is your power. That's above the word log. In the front, we're going to deal with this first. It might be helpful for you to realize it's top, bottom as one thing. So we have now the log of a product. So we're going to say log base 7 of 3 plus log base 7 of x squared. And the only thing left to deal with in this parenthesis is what? The squared. Where do we put that squared?
In front of the log.
In front of the log.
Oh, I think we put it in front of the whole thing.
Log base 7, no, because
It's only x squared.
it's only x that's being squared, so it goes in front of this log. Log base 7, whoops, I missed the 2. 2 log base 7 of x. That's the first part. That's the top. Log base 7 of 3x squared becomes log base 7 of 3 plus log base 7 of x squared. Powers go in the front. Here's the top. A lot of you did the bottom correctly, but didn't put it in parentheses. So on the bottom, when you separate, this becomes log base 7 of 5 plus log base 7 of y cubed. Very much like the top, but again, in parentheses. The 3 is going to go in front of the log, and the minus is going to be distributed. It's going to go in here and here. So it's minus log base 7 of 5 minus 3 log base 7 of y. And that's it. That's expanding. You don't need the parentheses around the first two.
You have to distribute the negative to.
Yeah, this is your final answer. Log base 7 of 3, 2 log base 7 of x, log base 7 of 5, and 3 log base 7 of 5. When you're simplifying and expanding, there's no parentheses and everything's as simple as it can get.
You wouldn't, would you have to put, like, because log base 7 of 5 and log base 7 of 3?
If you memorized your base 7s, then you can go ahead and put in an approximation, I guess,
No,
there.
but can you combine those because they have the same base?
They all have the same base. We can combine them all and you know what you get?
The same.
Good question.
Well, okay, so then, okay, it says,
The directions are to expand.
yeah. So, okay.
I don't want you to combine, so you take the log of one thing only. That's what we mean by expand. Obvious, tell me what the next kind of question we look at is going to be.
Something
Contract? Is that what you're going to say?
Simplify.
Condense. Cheater. So you're going to take this and turn it back into the question. Again, it's all about order of operations. Any questions on this one? On this one?
Yeah,
Ask now because later it's going to get, this is easy. Later,
I was wondering if we could do that.
that's a great idea, but I want to know if you have questions on B for this example. If there's anything in here you don't get, because these are the same properties as with exponents, only now you're doing it with the word log, which is nothing more than that. So when you start at the beginning, you have the log of a quotient. So we take log minus log. Log of top minus log of bottom. Log of a product becomes the sum. And when you have a power in what you're taking the log of, that drops to the front.
Wait, I don't get why that's along with the front.
Product means multiplication. 3x squared means 3 times x squared.
Okay.
Log of a product, 3x squared is a product. And 3x squared divided by 5y cubed is a quotient. And then when you get to the x squared, the 2 is a power on the x.
Okay, can you scroll down a little bit? Okay, so when you condense it, how do you know?
We don't know, we don't care. I just want to know if you get this. And we're going to do condensing in a minute.
I know, but like, where would you start?
We don't. This isn't a condensed question. This is an expand question.
Okay.
Okay, and we'll get to the condenses because that's important. Where do you start? Everybody good on this one? But don't, I just want to make sure, Dayton, that you're good here.
Yeah.
We'll get to those in a second. Try this one. See if you can expand this one. Alright, so what do we do first? Which property?
Product.
Product. Uh-oh. Let's change flavors. Log of 5 plus log of x cubed. Because you can't put the 3 in front of log base 5 of x because the only thing that the 3 is a power on is x. So you have to separate the product first and then the powers second. Same with quotients. You do the quotients first, then products, then powers. What do we do with that 3?
Put it in front of log.
In front of the log. So log, common log of 5 plus 3 common log of x. Common log of 5 plus 3 common log of x. That's as far as you can go. Now we go the other way. Now, my recommendation to you is to do it in this order. Power property first. So the first thing we're going to do is power properties if we can. That means we're going to have natural log of 8 plus the natural log of 25 minus the natural log of 10. What do you do with the 2? Yes, you do know. Look at your properties. Look at your properties. You have them written down, right? Is there one where you have something times a log? The third one, perhaps? And what do you do with that something if you go the other way on the property? You put it as the power on the 5, right? So 5 squared becomes 25. You're making the face. Are you good or no? You sure? If you want, we can do this. You're going to get tired of doing that really fast.
So when you do the property, you just do it on part of it. I can put it right there.
I didn't just do it on part of it. I just simplified 2 natural log of 5.
Yeah, that's what part of the whole thing.
Well, it's not 2 parentheses natural log of all of it. It's just 2 natural log of 5. The first thing you need to do is see if there's any power properties. Power properties are something times a log or log of something to a power. This is something times a log. So we're putting the 2 back on the 5 and squaring. The next thing you do after you do power is left to right, product or quotient. It doesn't matter which comes first. Do them left to right. People will argue with you on that. I'm not going to argue. You do what you want. I'm just telling you left to right tends to work pretty flawlessly, and you don't have to worry about what goes where. We have log plus log. What property? Log plus log. Product property. What do you do with what you're taking the log of? So we get the natural log of 200 minus natural log of 10. It is.
It's natural log of 200 over 10.
Not yet. Right now, we need to make sure everyone got the 200. Okay.
Why did you,
Because I said go left to right, product or quotient property, whatever comes first. Left to right would be add these two together. What property shows you adding two logs? The product property. What do you do with the 8 and the 25? And that gives you 200. I didn't know. This says minus natural log of 10, so does this. All I did was combine this and I got this. Do you see that?
Yeah. It's not just because it's addition.
It's because we're going from left to right. If this was a minus, I would have done the quotient property.
Yeah, but left or right all the way across the whole.
Okay, so all the way across the whole thing, when you're going from left to right, here's the first two things you combine.
Oh, okay.
That's left to right. That's what I did. I combined them.
Okay.
Now I'm going to combine these
Later.
right now.
Okay.
Natural log of 20. What property says log minus log? Quotient property. What does it tell you to do? Divide them. 200 divided by 10 is 20. Folks, we will not, or at least I won't be, I am not going to write natural log of 200 over 10. Now you're welcome to do that, and if that helps you right now, then by all means do it, and I promise you, you will never get marked down for showing work. But you're going to get tired of doing natural log of 200 over 10 when you can do it in your head. If that's 200 over 11, you would leave it. Natural log 200 over 11. Nothing you can do. But here, this simplifies to natural log of 20. Right, Bryce? You're drooling on your paper. Try this one.
And really
Okay, first one we do on this.
Power.
Power property. What is it?
log 7.
Yeah, that's my guy.
All right. Hey. What? So then left to right, we're going to get common log of 54 minus common log of 9. And then when you're subtracting logs, what do you do? Divide. 54 over 9 is the common log of 6. And you got to circle it. Or maybe you want to put a cloud or something. Good? All right. Now, all right. This is because I'm pretty sure, judging by the underwhelming response of people volunteering to memorize one of our basics. And I only wanted if you each did one, we would have been fine. Well, if you would just do one of them, yes. You can have anything you want. Yeah, you can have an A in the next class too. How about that? But nobody really wanted to do this. So, you seriously want to have this conversation? Do you want to do it, Ivory? You give me
$1 billion, I'll do it.
I'll give you whatever. You want $1 billion? I will get it. I will call Warren Buffett and I'll get him to donate. I'll tell him I have this kid who memorized. He can't. Because it's too much. You guys can't even remember the 3 properties. And yet you're one. The logic is really solid here. All right. So when you don't have, what are our favorite bases? 10 or E. When you don't have base 10 or base E, and you didn't take the time to memorize whatever base you do have, you're pretty much in trouble. So I think they needed to come up with a way to change the base to a 10 or an E, which they did. And you can copy this down. It looks way more complicated than it is because this is a generic form. This says if you have log base C of A, you don't really know your base C's, whatever it is. It could be 3, it could be 2, it could be 5, it could be 11. It could be anything except base E or base 10. You don't like the base that you have, and you want to change it. This tells you you can change it to log base anything you want of whatever you were taking the log of before. And divide it by log base anything you want, as long as it was the same as the base you picked on the top, of the base that you had prior to that. And if you can look at this, you can see how close and confusing this is to the quotient property. You don't have log divided by log in the quotient property, but that's the common mistake.
Where did you get the B? Is that you're giving
B is pick whatever you want. What's your favorite base?
5.
Really?
10.
Well, you need to have a favorite base. And it should be one of two numbers.
36.
Or, what's your other choice, Andy? E. Now I've known 10 a lot longer than I've known E, so I usually go with 10. And that's called common log. You would do log base 10. You can pick anything you want. But 99 or 999 times out of 1,000, you want to pick 10 or E.
Okay, so we're going to be given a problem that would be...
Bear with me.
Yeah.
Okay, just hang on 1 second and let me go through. I give you this because this is the change of base formula. Okay? But again, we are only concerned with using base 10 or base E, which would be common log or natural log. This is the one for common log, base 10. This is the one for natural log, base E. It doesn't matter which one you do. Makes no difference. And you're not going to be any more correct by doing natural log than you will with common log. So if you're going to use common log, you're going to do log of A over log of the original base. If you're going to do natural log, it's natural log of A over natural log of the base. And it doesn't matter which one you use. And I'm going to show you an example here in a second. Whatever you're taking the log of stays on the top. The base is what you're taking the log of in the bottom. Everybody good here?
Yeah.
Let's look at this example. Base 6, I'm not very good at my base 6s. I know that log base 6 of 24 is 1 point something. If you don't know that, you're still not dialed in on the definition of a log. Definition of a log says 6 to some unknown power is going to be 24. I don't know what the power is, but I know it's more than 1 because 6 to the first is 6. And I know it's less than 2 because 6 squared is 36, more than 24.
Is this from the last one we recorded last night?
I don't know. It's a good question. But what this is about is changing the base. I'm going to change this to common log of 24 over common log of 6. Now again, it's very confusing. This change of base property is very confusing, Tyler, with the quotient property. When you are doing change of base, you need to do the log of 24 on the top and divide it by the log of 6 underneath. It is not the log of 24 over 6. This is find the log of 24 find the log of 6, and find their quotient. Those of you with multifunctional calculators can do it in one shot. You know your answer is going to be right by, it's got to be between 1 and 2.
What's the point of putting it as fractions?
How are you going to evaluate log base 6 of 24? I'm open to suggesting. Now again, some of you have a magic calculator. You can do this on your calculator. But in this class, you have to show a change of base. 1.4. That means 6 to this power is 24. Now again, and I'll talk more about this in a few minutes when I pass the quizzes back, some of you are not using any common sense. You punch things into a calculator and you don't even give any thought as to what the answer is going to be. This answer, you need to know in advance, is between 1 and 2. And if you get 4,398 for your answer, it's wrong. It has to be between 1 and 2 to even be acceptable. All right? Try this one. I'm going to do this one with natural logs just for fun. Natural log of 11 over natural log of 5. And when you divide natural log of 11 by natural log of 5, what do you get? 1.490. Uh-oh. I got 197, 3 something, and 4 something.
490.
Yeah, tell me.
1.490. 1.490.
How could you check it? There's nowhere to plug it. 5 to the 1.490 should give you somewhere close to 11. See me after, and I'll be glad to help you.
That's 11.0.
Make sure you use parentheses before you divide. Make sure you use somewhere in your calculator there's parentheses appearing, right? Isn't there parentheses for the 11? Okay, now I want to show you. Well, on this stuff you need a calculator. I haven't looked at this test yet. So here's some examples of where logs come into play. This is a simple problem that talks about time it takes to get a certain amount of money, where I sub 0 and I, this is your initial amount, I sub 0, and this is how much you want to end with. The time it takes to get the amount you want can be modeled by this function, natural log of I over I sub 0, all divided by 0.049. Not the log of 0.049, just 0.
Wait, where do you get 0.0?
It's written right here.
Like, where do you?
It's this, I'm telling you right now, Cole, this is the formula. It's like saying a squared plus b squared plus c squared. How did that come up? I'm loading you up. Here it is for free. Okay, so you don't have to derive it. You don't need to know where this came from. Here it is. They want you to expand the expression for t. So t is going to become the natural log of, how do we expand the top? Natural log of I minus the natural log of I sub 0. All that is over 0.049.
So you would do a minus again.
Nope, this is not a log. And this is not the log of a quotient. You've got to know that those properties only apply. Now we want to know how long it takes for our money to double. So how much did you start with? 1,500. How much do you want to end with?
3,000.
So natural log of 1,500, sorry, natural log of 3,000 minus the natural log of 1,500 over 0.049. Again, if you're using a multifunction calculator, just make sure you use parentheses correctly. You need parentheses around the top, and you probably need parentheses around what you're taking the log of.
So you started with 1,500.
That's what they said, you start with.
Okay, and then you multiply that by 2.
They said, how long till your investment doubles? Not off the top of my head.
How are you going to use the quotient?
Because this is the log of a quotient.
Okay.
You see natural log of a quotient?
Yes.
That's quotient property.
Oh, so you plug in.
I'm not plugging in anything. Right here, I separated this as the log minus log.
Yeah, that's fine.
That's all I did on this expansion.
And then, so you're not plugging 1,500 in for I sub
In
0.
question A, all I did was expand.
But in question B,
It says how long till your money doubles. How much did you start with? In for I sub 0, 1,500.
how do you know that the 1,500 is I sub 0?
Because that's your starting amount. It says you want to invest $1,500.
But why would you think for I?
Because I is the how much it grows to. It tells you all
Oh,
this right here.
so, okay.
We're not trying to trick you on this, Jane. I have other things to trick you on later. So natural log of 3,000 minus natural log of 1,500 divided by 0.049. I want to say we're going to go 14 years, a little more, 14 and a half. 14 point. Double your money. Sorry? Oh, sorry. Okay, here's another example. We talked about this on Friday, the Richter scale. You have a Charles Richter, the seismologist. This is pretty good. The scale is logarithmic, so each unit increases 10 times on the seismograph. And it tells you that that's 30 times the energy, which I don't understand that because I'm not a seismologist. But on the Richter scale, when you go from a 6 to a 7, the magnitude of the earthquake goes up by a factor of 10. It doesn't just go up a little bit. Before I came to California, I thought a 6, a 7, how different could they possibly be? Huge. Here's your formula. The log of I over I sub 0, where I is your initial intensity, and I sub 0 is the magnitude of the Richter scale. So if the intensity of the quake is 50 times of another, we would put a 1 here and a 50 here. So if you find the Richter scale number, what's the log of 1 divided by 50? And you don't need to separate that to use parentheses correctly. What's the log of 1 divided by 50? 1.6989. So you're going to go up by a factor of 1.698. So 99, 1.699. You don't, because you're doing the log of 1 over 50. You're welcome to do the log of 1 minus the log of 50, but why would you want it? There's no reason to. You got? And I don't know what it does. You do the log, parenthesis, 1 divided by 50. Close parentheses. Come see me after, I'll help you. The third example.
He's getting a negative.
Same number, but negative.
Yeah, it's the same number, just negative.